Okay, where do we want to start?
I have like 6 questions, so unless somebody else wants to start, I can jump in.
I'd say far away. Most likely your 6 questions are going to be pretty similar to everybody else's.
Okay. I did have a question just on the homework that you're showing right now. When
Yep,
we're giving the answer, do you want us to show how we calculated it, or do you just want the answer?
I'm fine with just the answers, especially on these.
Okay.
I don't think there's any of them that ask you to kind of, well, there's a couple where you need to explain
What it means.
these two where it asks for it, or it says justify your answer and explain your answer. Those two you need to justify, and explain. The
Okay.
rest are just answer.
Okay. I was trying to figure out how to write out the calculation on here. I
Yeah,
thought,
don't
oh,
worry
this got
about
up
it. Yeah, it's a
ridiculous.
waste of your time to try and write everything out.
Perfect. Thank you.
Just put your answers is fine.
The rest of my questions are all related to the critique, so I'll let somebody else jump in on the homework part.
Okay. Any other homework questions? I know somebody had asked about
Yes, it's me.
Laura,
And
yes, about did you get it working in Sas Studio?
no.
Okay.
So I need you to stepwise me through that because
Sure.
I went to histogram, I typed in all the detail, and
Okay.
it still doesn't work.
So you're trying to get the code stuff loaded, right?
Correct. Yeah.
Okay. So let me show you how that works. So in Sas Studio, let me just get the code up here. We're talking about all of this code here in week 4. This stuff is what we want to be using. So if you go to Sas Studio and you just really, it works with any task. You just open any task you want. I happen to use the histogram task only because if I double click on histogram, you'll see over here, it doesn't put a lot of code in there. It's a very simple code for histogram because you have to do a bunch of crap first before it really generates any code. But you could have just as easily double clicked bar chart. And then you can see it's got a similar set of nothing to it, right? So the whole point is just open any formula, right? Up here, any of these functions, doesn't matter what you have, but once you have one of these open, if you click on edit, you'll see that it creates this new one that says program 1. And now, you can get rid of these. These are completely useless. Now all you care about is program 1. Because all it does is it creates a copy of the code and then calls it program 1 because it doesn't let you mess around with the code of its programs. It lets you, if you're going to mess around with it, it's going to, you're going to have to call it something new because it's no longer going to be their, default histogram or their default bar chart or their default scatter plot or whatever it is. But in any case, once it's all here, the first thing I do is I just highlight everything and delete it. And I start fresh. So here's a nice fresh code screen. And then if you open up our SAS document and go to this, all you have to do is highlight all of the code, which is the stuff in bold right here that starts at data binomial and ends down here. And I just do Control C and put it in here, Control V, and there's my code. And so now if I want to run a binomial, all I have to do is change these numbers, right? So if I want to have a sample size of 6 and the probability of a success is, let's say, 25%, and I want to know the probability of exactly 3 out of 6 successes, then I highlight just that portion of it and hit run. And there's my answer, 13 point something percent. And then if I go back to my code and I change it, highlight it and run it again, right? I'll do that. And then when we want, see, it has it right here for less than or equal to stuff. And you'll notice that here data is in purple and here it's not, because this text is messing with everything. So when you have text that you don't want it to mean anything, you have to put these little things in front of them and then the thing after it. So it's /* to start it, and then * / to end it. And that basically, and you can see that's now, I know it's kind of hard to see. If I make it bigger, there we go. You can now see that this is in green, and green text is basically just saying it's just text, it's not code, SAS will ignore it. And then you can now see that just like this data is in dark blue, so is this, because that's telling you that SAS is recognizing this as it's going to run a binomial on the following data. And all you have to do is change these. But this, the difference between this one, right? This is a PDF, so this gives you the probability of an exactly something. So exactly 3, exactly 2, exactly whatever. And then a CDF is a cumulative distribution function, and it sums up. So this will give you the probability of 0 up through and including whatever your X is. So in this case, if I highlight this and run this, that gives me the probability of getting between, it's the probability of 0 up to and including 8 successes when the probability of success is 1/2 and I have a sample size of 20. So it's kind of like flipping a coin 20 times. What's the probability of getting 8 or fewer tails? Well, that would be the probability. Okay.
Well, I don't know why mine's not working.
Sorry, Laura, what were you saying?
Well, it's just not working. I put that in and it's not working.
All right. Share your screen.
Well, I erased it because I was so frustrated.
That's all right. Still share your screen so I can walk you through it, make sure you're doing it right.
Well, I didn't do it and I erased it, so I'll have to work on it tomorrow after I do this video again.
Okay.
Okay, so I may be bugging you again tomorrow.
Okay, no problem.
Okay.
All right, what else?
How about go through 4.46 B, C, and D?
4.46.
Homework for 4.46 B, C, and D.
Okay, so quality control, examination, 40 price. Okay, yeah. So the hardest part about 46 is understanding, well, is figuring out what your success rate is, because you have to use the description that they give you and then figure out how many of these categories up here fit that description. So when B says they want to know the probability that exactly 6 out of your 20 are defective and not repairable, well, that one's easy because they tell you exactly that 5% of all of their returns are defective and not repairable. So we know that our probability for this one is 5%, and we want to get 6 out of 20 with 5%. So that's when we go up here and we say we've got a sample size of 20. Our probability of a success is 5%, and we want to know the probability of exactly 6 of them. We would highlight all of this and run it, and that would be your answer. Really, really small. Now to do the next one, part C, of the 20 return products, 6 or more are defective and not functioning properly. Well, here is 5% are defective and not repairable. All right, so that sounds like defective and not functioning properly. 45% are defective but repairable. That also sounds like defective and not functioning properly. And then 35% have scratches but are functioning properly. So that obviously doesn't fit. and then 15% have no problems at all. So that obviously also doesn't fit. So for C, it looks like we're looking at these two groups put together because they both make up, or contain items that are defective and not functioning properly. It's just whether or not they're repairable. And so that's 50%. So 50% of their returns are defective and not functioning properly. So that's going to be the success rate, right? That's going to be our P for part C. And then of the 20, they want to know 6 or more. Now here's where it gets tricky with binomials. If we want the probability of 6 or more when we're talking about a binomial, then that's basically the probability of 6 plus the probability of 7 plus the probability of 8 plus ... all the way up to the probability of, in this case, 20, right? Or whatever our n would be for our sample size. And in this case, we're sampling 20 of them. Well, we don't have a function that adds up like this. We have the CDF function, but the CDF function gives us the probability of 0 plus the probability of 1 plus the probability of 2 plus ... up to some probability of some x value. Well, that's not what we're asking for because we didn't start at 0, we started at 6. But you can see that if we're looking for 6 or more, if we had the probabilities of 0 ... that's not minus, through 5, that's everything that's missing from 6 or more. So if we do 1 minus the CDF of 5, that's going to give us 1 minus this whole big probability of 0 plus probability of 1 plus probability of 2 plus ... plus probability of 5, right? Because this is the CDF of 5 right here. That's what this is. And if we take all of that junk and subtract it from 1, it's going to give us the complement, i.e. whatever's left over. And what's left over is the 6 through 20 that we want. So that's what we would have to do for that question, is we would have to run a CDF of 5, and then we would have to subtract it from 1. So we would go back to our code. We would run the CDF. We have a sample size of 20. Our success is 50% because that's that 45% that are repairable and the 5% that aren't repairable. Put them together, that gives us 50. And we want to set this at 5 because that's going to add up 0 through 5. If we highlight and run this, that gives us this answer of 0.02. And then if we subtract that from 1, that'll give us the correct answer. And in fact, if you want to be fancy about it, you could even put 1 minus in here and get your answer that way. And if you run this, you see that you get the complement, the 1 minus it, and that's your actual answer of 0.97, blah, 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 right? So you can put the 1 minus in here if you're working on the complement to, have it do the math for you, but you could also just very quickly just stick it in a calculator. And by the way, folks, you can do all of these, in a TI calculator super easy as well. So if you don't want to mess with SAS and you have a TI calculator, just go do it in a TI calculator. It's really super easy. You go to second vars, which brings up your distribution. And you go down to binomial PDF if you want to get this one, right? Where it equals something. And binomial CDF for this one. So we'll do this last one, this binomial CDF. We hit enter, and it needs no number of trials, which is 20. and needs to know the probability of success rate, so 0.5. And then needs to know the X value, right, which this case was 5. And if you don't have the fancy one that gives you the menu, what it's going to do is when you run a binomial CDF, it's just going to put binomial CDF and open parentheses, and then you just have to put these numbers in yourself. So you just, so if you have like the 83s, it's the 84 plus that has these nice little menus for you. If you don't, if it doesn't give you those menus, then all you have to do is just Google TI-84 binom CDF. And I guarantee you within the first 5 links, one of them will give you the syntax of what it needs. And it'll say, okay, well, you need inside the parentheses to put number of trials, comma, probability of success, comma, X. And that's what you put in here. And then when you hit enter, this is that same number that we got before, remember? And then now we just have to subtract that from 1. So if you do answer -1, yes, I know it's negative. That's because it's easier to do that than to try and do 1 minus the previous answer. You just know that your answer is positive, right? It's not negative. It's because 1 minus something is going to be the exact same thing as something -1. It's just going to be positive versus negative, right? 1 minus a quarter is 3/4, and then 1/4 minus 1 is -3/4. It's always the same answer, just with the different sign. So you can always just do answer -1 to save you the hassle of trying to do 1 minus, then type all this crap back in, which is a big pain in the butt, right? Sometimes it'll let you do this and hit enter, and then it puts it there, right? And it does it for you. But it's just, learning how to use the tool. So that's how you do those. Does that answer your questions for 46?
I wish I was that quick at it.
Yeah, it's the hardest part is, in my opinion, is understanding what the p-value is. But it's all about, it's more important that you guys understand basically what a binomial is, and not so much how to get it out of technology. You can go back and watch this video over and over again. Do it nice and slow, and you can do it by hand even if you want, or you can, there's all sorts of online tools. If you just, went to Google and did binomial probability calculator right there. And then I bet you this first one, oh, look at that. Probability of success, 0.5. Number of trials, 20. Number of successes, we set it to 5. Calculate. Here's the probability of exactly 5. Here's the probability of less than 5. Here's the probability of less than or equal to 5, which is exactly what we wanted, right? And then here is greater than, which is the complement. That's the actual one we want. And then here is greater than or equal to 5. So it gives you all sorts of extra things all at once. So you could do that one. I don't care which technology you use, because the school no longer cares. It's just more important that you guys understand what a binomial is and how it works and what it tells you, and then you go from there. All right, what else?
Okay, all right, what about D?
D.
4.46D.
Well, here it says none of the 20 return products has any sort of defect. So we're looking for none of them has any sort of defect. Okay, so what's the probability of not having any sort of defect? Well, 5% have this kind of defect, right? 45% have this, so there's 50. Here's 35%, right? And then, oh, here we go. 15% have no defects whatsoever. So we want to know the probability that none of them has any sort of defect, so that probability of 0, right, when it's 15. So it just depends on which one you want to use, right? We can use the calculator and do second vars, which is the distribution. We're doing a PDF this time because we want to know exactly something, right? It's not a cumulative, it's none. So it means that exactly 0 have a certain characteristic. So we're going to choose this. Again, trials is 20. Now our probability of a success is 15% because only 15% of them had no defects whatsoever. And we want to know the probability that exactly 0 out of 20 happened that way. There it is, 3.8%, right? If we want to do it in SAS, again, we're doing the PDF. Make that 15%, make that 0, highlight this one, run it. There you go, the same 3.8%.
Okay.
So I think I confused mine now that you're saying that. I look at mine and I have that for my, all of the 20 return products have some type of problem. That's what I had the 0.038 as that for A,
Mm-hmm.
but it's also for D. So
So
all of the 20 have some type of problem. None of the 20 have some sort of defect. So I think the word problem and defect are what's screwing me up.
yeah, I can see what you're saying. I guess another way to think about it is if none of them has any sort of defect, none of the 20 has any sort of defect, then we can do 1 minus the probability that all of them have some sort of defect,
Gotcha.
which would be 1 minus 0.85 to the 20th. And it's going to be pretty close to 0, actually.
Well, so that's what I had 0 originally, but now I'm.
Well, I'm thinking that maybe there's 2 ways of kind of interpreting this. I think the 0 way is better now that I think about it. Because none of them has any sort of defects. I mean, you can kind of interpret it both ways.
I know, that's where I'm getting confused.
Yeah. See, that's the biggest problem with probability questions is unless they're written very explicitly, it's very easy to get different answers depending on how you interpret them.
Okay.
So you have to be very careful and make sure that you write things very clearly, right? So it does get kind of that's the one crappy thing about homework and test questions is they can sometimes be interpreted more than one way. The nice thing about just probability is, I mean, if you were doing this, you would know what you were looking for and you would do it the way that you wanted it. So there was only one and only one answer. But yeah, it's weird that they're different. You would think that they would be the same, but we're asking two slightly different questions.
And I'm very literal. So I was like, okay, well, defect means it can't be used at all. And a problem means there's a little dent, but you can still use it. So I was reading way in between the lines on this.
Yeah. I mean, has no problems. To me, that's the only one that doesn't have any sort of defect. And if we look at the other, everything else, that is 85%. None of the 20 has any sort of defect. So if we did it the other way, it is really close to 0. If you do, so all 20 of them, and this is 85, and then we do 1 minus that. Because if we just do the CDF of 20, 85, and 20, it's basically going to say, give us the probability of, oh, see, but there's the problem. That's why I think this is wrong, because the CDF adds up all the probabilities. So that's the probability of one thing having a defect, 2 things, and the only thing that's left over is, yeah, I don't think that's right. Now that I'm thinking about it, I really think it should be the first way.
It should be 0?
I think it should be the first one that we got. I think it should be
0.38?
Yeah, because if think about it this way, okay, if we do, because this is what this is what people normally do is they run this one. Oops. They run this one. And they basically get that number. And they do 1 minus that, which basically gives them 0. But that's not really what you want. Because
so would it make sense that both of those have the same answer then? A and D?
well, the mathematically, these are doing two different things. When you do the cumulative distribution function up to 20, you're basically saying, what's the probability that none of them have some sort of defect? Because remember, 85% just means any kind of defect. So you got none of them, plus one of them, plus two of them, plus three of them. You're actually, it should be 1 because you're looking at all cases, and that's not what you want. So there's another way. So this one won't work. There's another way to do it by hand, and that's the idea that if you had, what the hell?
So it'd be the probability for D, it'd be the probability in parentheses, some defect, which is 0, equals 1 minus 0.85 to the 20th, right?
Yeah.
Which would gives you about 0 basically. But the first
really,
one,
really,
A,
really small.
yeah, and so A would be P times the 20.
See, but to me, those are two different questions. If you take that all of them have some sort of defect out of 20, and then do 1 minus that, that's not the same thing as saying none of them has a defect, because the complement of none is not all, and the complement of all is not none. That's the problem with complements is the English language, it feels like that's the case, but it's not. The complement of none is 1 through 20, and all is 0 through 20. It's just it's two completely different questions. I think the only way to really get this question correct is to do it the direct route, which is this one. And that should be the correct answer for this one.
So I got 0 when I did it, but I interpreted defect to mean didn't function properly. And the one chunk of them have scratches but function properly, so I didn't consider that defective. I don't know if that was their intent, but
yeah, well, again, you can see how without really strict wording, it can lead to different, completely plausible and very easily defendable answers.
Well, that was stressful, but thank you.
Yes. So
I've got a quick question. I'm sorry. Are we referring to D?
D in 4.46. Yes.
Okay, that's what I thought. Thank you.
Yeah.
Good grief.
And I'm completely confused now.
I'm just going to take D off the homework.
I think that would be helpful because
like, you can interpret it a couple different ways, but I can tell you guys that because of the interpreting of what is a defect and what is not a defect, right? What, the idea that you could say small scratches is not really a defect. Sure, you can make that argument. If we all agree that anything other than pristine is considered a defect, right? So a scratch, a dent, or just doesn't work or whatever, those are all defects. So if we can agree on that and get rid of that other possibility, then that leaves us with only two things to think about. And that is, okay, well, if it has no defect, then the probability of a success is only 15%. because only 15% of them are completely 100% bereft of defects, right? Including scratches and that kind of silly stuff. And if we all agree on that, then this becomes our only possible answer. And the whole 1 minus 0.85 to the 20th is logically not correct. It's what the answer key says, but now that I think about it, it's not right.
Okay, so we don't have to do D.
You don't have to do D.
Okay, that makes me happy.
All right, what else?
Let's see.
I have a confused question.
451, C and A.
Okay, well, 451A, you're just going to use all the probabilities given here and run a normal binomial where your sample size is 2,500. Your probability of a success is 1 out of every 1,000. So as a decimal, that's 0.001 because that's 1/1000th. And you run that, right? What's the probability the firm will have more than 5 sales? So you're going to do 1 minus the CDF of 5. So in SAS, you have to go back to your code. We have to do the CDF. We now have that our sample size is 2,500. A success, a probability of success, or in this case, probability of a sale. They make 1 out of every 1,000 people who come to their website has a sale. So 1 out of 1,000 is a 0.01, right? Because this is tens, hundreds, thousands. That's 1,000th, 1 out of 1,000. And they want to know the probability that they get more than 5 sales. So if we do a CDF of 5, that's going to be the probability of no sales plus the probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 sales. It'll add those all together. And then if we subtract that from 1, that will give us the probability of more than 5 sales. So if we run this and get to 0.958 and then subtract that from 1, that's going to be the probability of more than 5 sales. That's how you do A. To do C, you have to do a little math because you have to come up with the mean. And the mean is very easily just N times P. So it's just 2,500 times that 0.001. Right? So it's just basically this number times this number. And that gives you 2.5. So that means on average, they have 2.5 sales per day, which we all know it's impossible to have 2.5 sales, but that's what an average is, right? Some days is more, some days is fewer, but it means they have 2.5 sales per day. So to do part C, where we have to use the Poisson approximation to compute this, then we need to find the mean, which we have, 2.5. And now we go back to our lovely code. And if we scroll down, we'll see that we have the Poisson code, right? So if we highlight this stuff, and go put it into our code window so we can run it as well. Make this smaller so I can see what the hell I'm doing. And again, because of this text, you got to put the little things around the text so it just thinks of it as text.
Did you just pull that line out, or do you have to add those in?
You can pull this line out. I just like having it there so I know what the hell each thing means.
Makes sense. Okay. Thank you.
You know, so I know that this is the code for doing one outcome, and then this is the code for doing more than one outcome. Obviously, I don't need that because I've been doing this for 20 some odd years, but I think it's a good idea for you guys to leave that stuff in there just to remind you which one you need to use for which, or just write it on a piece of paper. And yes, you could just delete that entire line of code if you want to. But the nice thing about, and this code trick works for all coding kind of things, that if you put the little / this and then kind of its complement, right? So it's mirror image, then everything in between that is just ignored as just notes, right? It's just text notes. So again, for part C, we want to do the probability that it's greater than 5, right? So we have to do a CDF, and then we have to do 1 minus the CDF. The mean we just calculated was 2.5, and then the X value, right? We want to be greater than 5. So if we go up to 5 and then do 1 minus that, that'll give us the approximation. So if we run this one and then do 1 minus that, we can see that that number is really, really close to what the other one was. The two answers are almost identical. In fact, if you round to 3 decimal places, they are identical.
And you use the CDF, correct?
Yes.
Thanks.
Anytime you're doing a more than or a less than, you always have to use the CDFs.
So should you put the 1 minus in the code or no?
If you want to, or when you're done, you could just take this number and subtract it from 1 in a calculator.
Okay.
But yeah, you could very easily just put it in the code and go 1 minus and run it. So there's your answer,
Okay.
0.042.
Okay.
Yep.
And I realized I forgot to ask a question on 21.
Okay.
So I have A and B, I think. So on C,
What do you think A is?
I think A is the donor has type O because they're white,
Not because,
or okay.
given that they're
Sorry.
white. Yes.
Thank you.
Yep.
So then to compute the probability of the occurrence of the event, I ended up with 0.4489.
That is perfectly, absolutely 100% correct.
Okay, so then, don't ask me to remember how I did this. I just looked at my highlighted notes. Where I'm getting confused then is on, are the events W and T1 independent, and justify your answer. So
Okay, so let's take a look at how you got part B.
Okay.
Because
part B, I found my notes. Okay, so
I can show you it's really simple. You don't even have to look at your notes, because conditional probability is still good over total. It's just the total is now the given condition, right? So part B says T1 given W. So given W means we're only looking at the white donors. This becomes our new total because we're only looking at these. So if we add all of these numbers together, right? 36 plus 32.2 plus 8.8 plus 3.2, we get 80.2 or 0.802 as a decimal.
we divide 0.36 by 802.
Exactly. Within this new total, what is the good? Well, the good are the ones that have type O. So it's this over that, right? So 0.36 over that, and that becomes our answer. That's how easy conditional probability is. So we just calculated the probability of T1 given W. We did that. If W and T1, so if being white and having type O blood are independent, then by definition, the probability of having type O blood should be the same for the entire population as it is for the subset of just the white population, right? So when we do this and we get 0.4489, now if we just look at the probability of having type O, right? That's what T1 means, right?
Correct.
It's really stupid. I don't know why they didn't just put big ass O for probability of O, but whatever, right? So this is just going to be literally just add all of this crap together, right? That's the probability of having type O, because the whole thing adds up to 1. I mean, technically you would take these and divide it by the whole thing, but the whole thing adds up to 100%, right? So it's literally just 36 plus 7 plus 1.7 plus 1.5, which when we do that math, that gets us 46.2%. Well, these two are not the same.
So they're independent.
So
they're
they
not-
are not independent.
So they're
If they-
not independent. Sorry.
Exactly. If they were the same, that would mean they were independent. Because to be independent means one thing does not influence the probability of the other. And since the subset, right, the subcategory of whites has a different distribution of blood types than the entire population as a whole, then that means being white has a bearing on the type of blood type that you have. And this is actually true. We know that different races have different distributions of blood types. It's just some weird genetic thing. And so your race and your blood type are not independent, because one does in fact influence the other, right? Being whatever race you are will have an influence on the likelihood of you having a certain blood type. So
So
that's
W and T1 are not independent because of the probability.
because the probabilities are not the same. Basically, the probability of T1 given W does not equal the probability of just T1.
Gotcha. So then are the events W and T1 mutually exclusive? They're not mutually exclusive.
Very good. And why is that?
Well, I knew you were going to ask me that. Because the probability of T1 not including W, right,
Close.
is
So mutually exclusive means
mutually-
they can't
not-
occur
not
at the same
containing.
time.
Yes, sorry.
Yeah.
Would be 36.36.
Very good. And if they were mutually exclusive, that probability would have to be
0.
very
No.
good. Yes,
Oh my God,
exactly.
I have no idea what I just said. I have no idea what just came out of my mouth.
Okay. Mutually exclusive means that they cannot occur at the same time. They are mutually together exclusive of each other.
Okay.
So mutually exclusive is like heads and tails, right? You can't flip a coin and get both.
Correct. Got it.
So-
Got it.
So the mathematical way of determining if two things are mutually exclusive is to look at the probability of their intersection. So they're basically saying if you take the probability of T1 and, this means and, being white, so the intersection of those two, and if that doesn't equal 0, then they are not mutually exclusive. The only way for them to be mutually exclusive is if they equal 0. If you think about it pictorially, mutually exclusive means two things that don't overlap, right? So this would be, you know, all white blood cell people, and this would be all whites. And if this is how it occurred, then they would be mutually exclusive. But we know that's not true. We know that they overlap, right? And in this
Yes.
overlap is that 36% that we see right here in the table. And so because of that, they are not mutually exclusive.
That was exhausting, but I get it. Thank you.
Good. Yeah.
Okay, so are there any other questions about this? Because I have a question about the critique.
Go for it.
So as I was going through my study, I was running into, let me see my notes real quick, sorry. I was running into the question of, I understand the population. I'm getting confused on the sampling frame, the sampling text. So there's the sampling question, and then there is the question about data collection. So I guess I'm confused on where how the two are different.
Data collection refers to how they got the data, and the sampling frame refers more to the things that are sampled from. So let's say you want to know whether or not a new gosh darn it, medication helps lower cholesterol. So you go around and randomly sample from a bunch of patients, in a hospital.
Okay.
Well, your sample frame are just those patients in the hospital, and then the sampling method is how you got those patients, right? Was it a convenient sample where you just went and got the ones that happened to be in your ward at that time, or did you take the hospital and break it up by the wards and then randomly sample within each of the wards, which would be a stratified sample, right? Or did you do a cluster sample where you had a bunch of wards and you randomly chose a few of the wards and then took all the patients from those wards? See what I'm saying? So it's the sampling technique is how you get the sample, and then the other one is basically what's being sampled.
So in my case, it's a study, it's a observational study of past, it's basically looking at alumni donor information.
Sure.
And they're which this actually goes to my dissertation. So this is exciting for me to read this, but
Nice.
they went through and pulled a set of data for undergraduate students that graduated between 2004 2011. Then they whittled that down based on things that didn't apply to what they were specifically looking at.
Okay.
And went from 9,400 to 3,300 sample students.
Sure.
So in that particular case, the population is the 9,000 whatever that they were looking at. The sampling frame would be those that graduated, that were undergraduate, and the sampling technique would simply be reaching out to the school to pull their records and going through the donor collection. Is that?
Yeah, I mean, the sampling technique is kind of what we call a post hoc analysis, where you go back and you look at records after something has happened. So it's kind of a weird thing. I wouldn't get too bogged down in the details of what you would call it. Your population, I'm not so sure the population is those 9,000 students. It all depends on what they're trying to.
They're trying to see how taking online courses is a predictive variable for alumni giving.
There you go. So if they're trying to predict, then that would seem to me that their population would be all future students.
Future donors.
Correct. No, future students, because they're trying to predict from that population of future students who amongst them will be donors.
So these are folks who have already graduated.
Yes. So future alumni.
Oh, sorry. Got it. Sorry.
See what I'm saying?
Yeah.
Yeah. So the population would be future alumni, or you could even say the population is just all alumni, past and present kind of thing.
Gotcha. Okay.
Yeah.
As I was looking at this, I felt like there was repetitive, so I must not have been understanding it right. So thank you.
So, sometimes the things can be really repetitive. If you think back to week 1, when we talked about the sampling stuff that was going on in week 1, and we had the hospitals, the wards, and the patients, and all that with that, there was a lot of repetition going on with those as well.
Yeah.
Liz, do you have a question?
I do. I was hoping before we ended, you could kind of explain 4.26 letter B, and mainly that last one, I think it's with the probability of not B given C.
Yeah. So this one is these can get tricky. And what I always tell my students when they're doing these is some highlighters help a lot. So what I do is I figure
Yes.
out what the heck, you know, what in this table classifies with each of these things. So I'm going to start with yellow, and I'm going to say A is going to be yellow. So an employee works at high capacity. So working at high capacity, that's my A group, right? All of those numbers are all in my A group. And then if I change, right, and choose green, and then that's going to be my B group, and that's an employee falls into the highest extensive formal training category. So this one, and this one are green. I kind of leave it a little so I can see it's both yellow and green. And then C, I'll make C blue. Employee has little or no formal training. So little or no formal training, right, are my blue things. Okay, so now I come down here and I'm trying to find not B given C. Okay, so given C means we're only looking at the blue stuff.
But they work below the high level.
Well, no, I mean, we're doing not B given C. So the first thing we want to do is
But I
figure
mean,
out
in the, when you highlighted the blue, they work below the high level.
employee has little or no training. Oh, and works below the high capacity. Thank you. I didn't even realize that.
Yeah.
Works below the high
So it
capacity.
doesn't cover the yellow row.
Yep, very good. It only covers those. Thank you. Thank you. Yes. So now when we want to do not B given C, right? Well, C is we're looking at all the blue stuff. So amongst the blue stuff, which one of those are not B?
So it would pretty much just be what C is, which is point, I guess the sum of non-low, non-medium, little low, little medium, which is 0.14, correct?
Right, but it's 0.14 over what's our new total.
Oh, okay, that's where I got tripped up.
Yeah. So can we see that if this is our new total, this is what we're now looking for, right? That's considered our new total. And out of this new total, how many of those are not B? Well, all of them.
All of them.
So you get all of them over all of them, and this gives you a probability of 1.
Ah, that's what I just did. Okay.
And if you
Thank
think
you.
about
That's
it,
where I got tripped up.
it's basically saying not B in English would be an employee does not fall into the highest formal training, right?
Ah,
So what's the probability that an employee does not fall into the highest formal training given that they have little or no formal training and work below high capacity? Well, all of those people, right, don't fall in the highest. So that's why it's a 1.
thank you. I was scratching my head on that one.
Yeah, those are tricky. All of the some of those can be very trippy, and some of them give you 1s and 0s, right? So you got to pay attention to the details, and then it makes a little bit more sense.
Thank you.
Of course. What else?
Do you need for the critique that, do we have to turn that into turnitin.com, or did I read that wrong?
No, I wouldn't worry about it.
Okay.
You can, but I really don't expect any of them to have any problems.
Okay.
Can you give us prelims on the major project?
Prelims, no. Mm-mm.
I mean, like, give us like expectations,
Well, yeah, it's the major the final project should be more of dissertation style writing than what we've done so far. Right?
I
Everything
mean,
we've
I was a little surprised on the grading for the mini project. I just found that the misses that I had on the graphs were graded so, I guess harsh.
well, there's nothing to it other than the graphs, right? I mean,
Right, so, I mean,
and
I
there's
had,
only like 7 or 8 questions. So if you miss one out of 135 points, you got to figure they're going to make a lot. That's the
yeah.
problem.
So can you give us some pointers on the final project so we can be more prepared?
Yeah.
Agree.
I mean, look, I don't want to sound like a jerk, but did you send me your mini project ahead of time to get feedback?
Okay, good point. Okay.
I know
So, yeah, I mean, that's the best thing I can tell you.
I mean, I did send you some of my graphs. I
Mhm.
did.
Mm-hmm.
I did send you some of my graphs ahead of time, but I didn't send you my whole project.
Right.
I sent some of my graphs ahead of time.
Right. And did you get any of those wrong?
No.
Okay, then I think we're seeing the solution, are we not?
Okay.
What would you
But
say
on
the probability is?
Exactly.
But
Yeah.
on the major project, what are your expectations?
Well, the major project has different parts. So there are different expectations to each of the different parts. So I can run you through those parts and kind of talk about what I expect from each one. So let me just bring up the final project questions so you can see, right? So in part 1, you've got this data that's in an Excel file, and you're basically using that data to just get some answers, right? So here you get some summaries and stuff, and so this stuff is more like the mini project, as far as you just got some answers and then maybe just some brief explanation as to what's going on, especially when it says things like why or why not. You have to kind of justify what you're doing, but the rest of it is basically just do some computations. I can tell you right now that none of you are going to get 4 correct the first time out, so get on it, start working on it, and let me give you some feedback, because this one is very difficult. Takes a couple extra steps. And then discuss any assumptions and stuff, blah 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 blah. So this is the part 5, is where you kind of summarize things and talk about what you did, but the rest are pretty much just give me some answers. So nothing really big there. Part 2, you have a whole different set of data about these judges, and you're just calculating a bunch of crap, a bunch of probabilities, and then ranking some stuff. So again, this is really just homework level stuff. I mean, it's just, what are your answers for all of these, and then rank them. And then when it says prepare a report summarizing all of your findings, that's where you just give me, a couple paragraphs of basically doing that, right? Summarize everything, including any charts that you use and calculations, and kind of justify why you rank the judges the way you rank them, because you could rank these judges different ways depending on what you think is important and not important. And it all comes from kind of what you're computing up here, as to, do you think it's important that their things were appealed, or do you think it was more important that their things were reversed, or do you think it was more important that their things were reversed given an appeal? So because all those different things would give you different rankings, so you just decide on one and use that to justify your answers. Then part 3, this is where things get more dissertation-y. This is where you want to start thinking about, what are you going to do for your dissertation? And these are the steps that you would basically use. The first 5 would be what you would use to help you get prepared for your dissertation. So if you've already started thinking about your dissertation and you already have a research question in mind, then by all means use it for these first 5 questions. So when you describe the setting in your problem scenario and a short background information, that's where you describe the problem that you want to address, right? I mean, your dissertation, there's a problem, and then here's my solution, and then I'm going to go out and test it, and then here are my results, and then, here's my summary. That's kind of what your dissertation is going to be all about. So number 1 is, what's the problem? What's the thing that you're trying to address? What's the thing you're trying to fix? What's the thing you're trying to improve, right? And if you haven't gotten that far and you have no idea what your dissertation is going to be on, then just make it up. I don't care, right? I mean, that's why it's, whatever you want it to be. And
What
then
if it's qualitative study?
Well, if it's qualitative, it's qualitative. That's fine. You're just going to have to make up everything else as well, because for part 2, define exactly what you want to solve in the scenario and your solution plan. So that's where you talk about, how you're going to gather your data and that kind of stuff. Type 3, describe the type of data you collected. So that's where you just talk about, what you would have collected or what you have if you've already done. I mean, you can pretend that you've already done. I don't care if it's past tense, present tense, future tense, whatever. And then describe the variables. So are they continuous? Are they discrete? Are they qualitative? Are they quantitative? If they're quantitative, are they, good ratio level stuff, or are they just, nominal, ordinal, interval, all those kind of things, whatever you want to do to describe them. Then describe the methods you use to analyze the data. So based on what you're trying to solve, the question you're trying to answer, what are you going to do with your data? Are you going to run a simple t-test? Are you going to run a hypothesis test? And if so, what's your hypothesis? What's your null hypothesis? What's your alternative hypothesis? And then what analysis are you going to use on your data? Then part 6 is basically just a rehashing of everything we've done in the homework. So we've had questions in the homework where it said, what's the probability that something was greater than a specific value? What's the probability that something is less than, between, and so on and so forth. And in fact, next week homework, you are going to do these exact questions are in next week's homework. So all you're doing for part 6 is describing how you would get the solutions to each of these scenarios. Given a continuous random variable, and you want to find the probability that it's greater than a specific value, how do you do that? Well, if you want to find the probability that it's less than a specific value, how do you do that, right? If it's in between, how do you do that? And then how do you find percentiles? And then can you provide some graphs to visualize your solutions? Now that's a hard part for a lot of people. You're going to have to find something online that will graph things for you. But basically what you're looking for is, here's my normal curve because I have a continuous random variable. And if I want to know the probability of something being greater than, it's that, right? And the probability that something is less than something is that. And the probability that it's in between 2 values is that, right? So you're looking for those types of graphs.
Now, when you say provide a detailed step, I went into SAS, I clicked on, this task, or just show you the code?
Depending on however which way you want to do it, you can describe how you did it in SAS and provide the code. Yes.
And you're saying week 5, we're answering these
exact
questions in week 5. Can we use the same information, or are you asking for a different set of answers?
Well, in week 5, you're given the scenario of, a certain random variable has an average of 750 and a standard deviation of 100. What's the probability
so we're
that you
given
get something?
data in 5.
Yeah, okay. And so you're actually going to get actual answers. So in this case, instead of giving me actual answers, you're describing the steps and providing the code or whatever you did, if you use the calculator, whatever, to how you got those answers.
Sweet. Thank you.
And then, this is just the discussion part of your paper where you discuss your results and why you did what you did. And then they just want to make sure that you're doing everything in APA format. And I wouldn't worry about turning it in because again, it should be completely new stuff. But that's what I'm looking for. And we're not presenting it. So part 5, don't worry about it.
That was my next question. I was like, I don't see that anywhere on the syllabus, so thank you.
Yeah.
Nice. Okay, good.
Does that answer your question as far as what I expect out of this one? Laura?
Yeah, it's still just a lot of stuff though.
Sure is. That's why it's doctoral level course. Lots of stuff.
Lots of stuff.
Yep.
Okay.
All right. So I would suggest just, get going on the homework for this week. Make sure you get it all finished up. And then once you jump on next week's homework, it'll get you thinking about how you can write up question 6. Questions 1 through 5, like I said, can be on just any scenario you want. It would be nice if you could use a scenario that means something to you. So it'd be nice if you could use something that has something to do with your dissertation.
Do we have a meet session next week?
We do.
Okay, thank
It's our
you.
last one.
Okay.
So we can discuss this further next week as well.
You
Thank
say
you so
next week
much.
is the last meet session?
Yes.
Okay. Sounds good. Thank you all.
Okay,
problem.
Good.
All right.
Good.
Thank you.
Yep. Good night, everybody.
Good night.
All right, good night. Thank you.